equation, we want to state its domain and range, and we want to list all the transformations. So first of all, look at your organizer. This is the only reason I had you take it out. You don't really need it. We're not going to write in it, but I want you to look at it so you can get the information that we need on here. So you look at this equation. What type of equation is this? So when you look at the doors, which function is it? What shape do we expect? So it's a quadratic. Okay. So what kind of shape do we expect our graph to be? Yeah, that U shape or that parabola thing. Okay. So if you want to, and I'm not saying you have to, you might want a graph of the parent function to help you get through the rest of the transformations. So for each of these, because they're relatively new for us, I'm going to include the parent function. So remember, like you guys said, this is a quadratic, so it's a U shape. Its vertex is at 0, 0. Now that's a really important point for us because that's the point we're going to base all of our shifting and stretching around. And then remember that the parent function for the quadratic, when you plugged in 1 or you went over 1 away from the vertex, the point was up 1, and then the same thing on the other side. But when you went 2 spaces away from the vertex or plugged in 2, how high was that point? So in a quadratic, when you plug in 2, take 2, square it, it goes up to 4. Okay, so a little bit different than our absolute value. This is what makes it curved instead of just like a V, because it climbs at different rates. Okay, and if we went 3 units away from the vertex, it would shoot up 9 units because 3 squared is 9. So the further we get away from the vertex, our height is like increasing drastically. Okay? So I'm just going to take this and I'm going to do whatever the transformations say to do. So what are the transformations that we're going to be performing? And let's again work from like the inside out. So what would be the first transformation that we want to perform on the graph? So look at the equation. Good. Okay, so we would start, if we plugged a value in for x, the first thing we would do is subtract 2. And remember, that's a horizontal thing because it's happening inside the squared, and it's 2 to the right. So we're going to move the graph right to. What's the second transformation that's going to take place? No, that's the last. You guys are right that that's a transformation, but we're going to save that for last in case there's some reflecting or something else that goes on before that. So we're going to do the 1/2 first. So think about it. If you plug something in for x, you would subtract 2 first, and then you'd square it. Then you'd multiply by 1/2, and then lastly you would add 3. So I'm going to list them in that way just so I don't mess anything up, and so that when I reflect it at the right spot, so things haven't moved to a new location. So what is the 1/2 going to do? Vertical and then compression. Good. So it's a vertical compression. Hope it's okay with you guys if I abbreviate. You can abbreviate too. Okay. And I might want to remind myself that basically means any vertical distance that there was is basically getting cut in half or multiplied by 1/2. So if the vertical distance was 10 spaces away from each other, it's now going to be 5 because it's just going to get multiplied by 1/2. Okay. And then thirdly, you guys already said, what's our third transformation that's going to take place? The up 3, okay, the plus 3 that's happening at the end. So once we do these 3 things, we'll be able to see our new graph. Okay? All right, so I'm going to go ahead and do the first one. Try and color code them. So I'm going to go ahead and move everything right 2 spaces. Okay? So that means this vertex point, okay, it's going to get shifted right 2. And so will all the other points. And once you've shifted the vertex, the rest of the graph right now is behaving the same. So if you're 1 unit away, you're still 1 unit up from the vertex. Oh, yeah, that's left 2. Thanks. Yeah, right 2. Totally good. Thanks. Thank you. If you guys could tell me instead of just laughing. So thanks. All right, so we go to the right 2, and then the rest of the shape's going to stay the same. So you can either literally move every point right 2, or you can say, I know that this is the vertex point, and the way that this behaves is every time I go over 1, I just go up 1 above it. And every time I go over 2, I'm like up 4 above it. Did I put them in the wrong space before? I can't see the lines on my graph, so you guys will have to help me. Sure. Okay, so this is our graph after everything has been shifted to the right 2. Okay? That's only one of our transformations. So the next transformation is this vertical compression of 1/2. So you know what the outcome is supposed to look like if it's a vertical compression. You know the graph should look like it was squished vertically. Okay? The vertex is not going to change. That's why that point is so important to identify at the beginning. Since it's a vertical compression, it's changing the vertical distance that all the other points are away from that vertex. So like remember with your step graphs, if you had a step and then the other step was 1 unit away from it, but if we had a vertical compression by 1/2, the steps would no longer be a unit apart. Instead, they would be half a unit apart vertically. The same thing is happening here. So this vertex is still going to have a point to the right and left of it that are 1 unit away, and a point to the right and left of it that are 2 units away. The difference is how far away those points are vertically. So like this point right here is 1 unit above the vertex. So if we compress that by 1/2, how high will that point be now above the vertex? 1/2. We're just going to take the 1 and multiply it by 1/2. So it's only going to be half the distance from the vertex that it used to be. Okay, so those two are there. Now this point up here, how many units was it away from the vertex? 4 originally, right? So now we're vertically compressing that by 1/2. So you take a distance of 4 and you multiply it by 1/2 or cut it in half, and what do you get? 2. So instead of these points being 4 units away from where the vertex is vertically, they're only going to be 2 units away from where the vertex is vertically. So now we get this graph from this change. And does it meet your expectation? Ask yourself. Does the orange one look like if you took the paper to the green one and kind of squashed it from the top and the bottom, it would spread out like you see the orange one doing? Okay? So then the very last thing that we have to do is we have to move the whole graph up 3. And so I'll draw our final answer on its own set of axes so that we can see it clearly. So instead of my vertex being at 2, 0, it's now going to be shifted up 3. So it's going to be at 2, 3. Okay. Now, you can either literally shift every one of these other points up 3 and like count it and mark it in that spot, or you can follow the pattern that you saw before. The points that are a unit away from the vertex left and right are only half a unit above it, and the ones that are 2 units away are 2 units above it. So I can do that. So I can go a unit away and half above, and I can go 2 units away and 2 up. So this would be my final graph. Okay. So same transformations, different shape. We're going to list the domain and the range. Okay. So for the quadratic, what is the domain? All real. So left and right, the graph never stops at a certain point. You could go left and right forever and still find a place on the graph. So all real numbers. And what about for the range? So looking up and down, does it continue to go everywhere up and down like this? Good. Y is greater than or equal to 3. Because all the y values are above some minimum point, and you want to list what that minimum value is. And since it ends right at that point, we can include the equal to also. Okay? Thank you. All right. So this is a cube root function. You should know that because it has the cube root in it. Okay? So look at your organizer and look at the cube root function. And notice what the parent function looks like. And like I told you guys, I'm going to go ahead and start with the parent function on all my graphs because we're a little bit unfamiliar with them. So if you notice on the cube root function, okay, it has 0, 0, and it has the point 1, 1. It also has the point -1, -1. Okay. Then the next points are kind of further out because the next number we could take the cube root of really nicely is like 8. So until we get all the way out to 8, that's when we'll get up to 2. So that's pretty far. I don't need you to do any other points besides these 3 points, but I need you to have the right shape. And notice that the cube root and the cubic function both have these 3 points, but they're shaped differently. The cube root is kind of like the square root. It almost looks horizontal because it's so slow growing. So remember, this should have kind of like horizontal looking ends because it's really slow growing. Okay? Whereas if it was a cubic where all of this was being cubed, cubing stuff makes it grow really fast, so you would see it shoot up and down really fast. So I'm okay with just having these 3 points, but you guys have to have the endpoints facing the right direction. If these were like shooting up and down, I would take off points because that's not the right shape for the graph. Okay? All right, transformations. Somebody tell me the first transformation. Okay, so the plus 1 that's inside the radical is going to make us go left 1. Okay, what's the next transformation? Good. Okay, a vertical stretch. And then again, for myself, I'm just going to write a little times 2 right there. And that just tells me how far anything used to be from the vertex. I'm going to now double it, and it's going to get a lot further from the vertex. Okay, a third transformation. Good, vertical reflection. So you guys can just say vertical reflection, or you can say a reflection over the x-axis. Sorry, Hannah. Okay, and you might want to remind yourself over the x-axis, because when you're going to the graph to make these changes, if you list your transformations really well, I never even had to look back at the equation to make all my changes because I listed them out so thoroughly that I could just apply them. And then our fourth and final transformation in this case will address the number being subtracted at the 3, so we'll go down 3. Okay. All right, so again, we'll try to go through most of these on this graph, and then if I have to, I'll switch to another graph to see them. So first of all, moving everything left 1. Okay. So we're going to go just over to the left 1 unit. So notice you get those same 3 points all shifted left 1, and you should still have the same kind of curve going on. Then we're going to take and perform a vertical stretch. Now, don't lose track of your vertex, that middle point that started at 0, 0, because things get stretched away from that. That one gets to stay at its location on the axis. Okay? So this point is not moving. What's happening is, just like before, 1 unit over there was a point that was 1 unit above. So their vertical distance between them was 1. But I'm stretching that vertical distance and multiplying it by 2. So it used to be 1 unit apart vertically, but now it's going to be 1 times 2, which is going to be 2 units apart vertically. So this point needs to be 2 units above the vertex. And same with this one right here. It was 1 unit below the vertex. Now it needs to be 2 units below the vertex because we're multiplying that by 2. Notice we're not moving it left or right at all. It's staying lined up where it was left and right. We're only stretching it vertically. Okay? So now it should stretch down 2 units. If I can see where it is, that might be a business. All right, so what's going to happen is our graph still has the same shape, but it's been stretched out. Okay? All right, the next thing we're going to do is we are going to reflect. Okay? So vertical reflection, again, if it's on the axis, it stays on the axis. Okay? In this case, the x-axis, because we're moving above to below and below to above because it's a vertical reflection. So this point up here that's now above the axis needs to move to a point below the axis. And this point that was below the axis is now going to be at a point above the axis. Okay? And if you're like, oh, I don't know what happened. So our vertex point stayed, those points switched. And if you're unsure about the curve, pick another point. Like, oh, something was out here. If it gets flipped below, it's going over here. Something was out here. If it gets flipped above, it's going over here. So you can see that the curve now curves in that direction. Okay. Move it over in which direction? Like you're saying, just move it over to this way? Well, if it had been horizontally stretched before this, it would change if it was 2 or 3 or 4 or something like that. So I would stretch it and then I would reflect it. each time. All right, and then the last thing we're going to do, and I'll go ahead and create a new graph with our final product on it, is you just want to take the whole graph you now have and move it down 3. So again, it should have the same shape. It should just be moved down 3. Really cannot see where this is. So this vertex here at -1 just needs to go down 3 to be -1, -3, and these points that are 2 away from it vertically and 1 away from it horizontally. I think that's right. Sure. So here's our graph. Okay, so just shift it down 3. We okay with this? Okay, so same shape, or different shapes, but the same things happening to each shape as we go through. All right, what about domain and range for this shape? Good, so domain left and right, you don't see the graph stop at all. It keeps going left and right forever, so it's going to be all reals. And what about the range? All reals also. You guys might think like, no, it doesn't go above this. It does. Just remember, it's just growing like pitifully slow. So it just takes a long time to reach different heights, but it will reach all those different heights. So all reals. We'll do one more. I want us to do the square root because I want you guys to see one that has a different domain and range. And if you look at your parent functions on the front of your little blue doors, you'll see that the square root function does look a little different than the others in the fact that it only continues forever in one direction, not in both directions. So the first thing I would do again is put that parent function. Remember, we don't plug in any negative x values because to take the square root of a negative would yield an imaginary or complex number, and our graph only represents real numbers. And then we add the 0.11 and the 0.42. So you see on your door this parent function for the square root. All right, so transformations. The first transformation, we should move to the right 2. List them up here. Because of the -2 underneath the radical. The second transformation, just like we saw with the quadratic, because there's a 1/2 out here, that's a vertical stretch or compression. And in the vertical terms, when it's less than 1, it's a compression. So a vertical compression, meaning the height of all of the points, the distance away from the vertex that it is going to get squished down half as much as it was before. We also have a vertical reflection because of the negative attached to the 1/2. Remember that means over the x-axis. And then lastly, we would move everything up 1. Are you guys okay with my list? I made the list this time instead of you guys, but you seem to be pretty good at naming them. So remember that all the changes are going to revolve kind of around your vertex point. So the first thing you want to do is shift everything right 2. So here's my vertex point, okay, and I'm just going to shift it to the right 2, and every other point along with it, which means you can literally count 2 over for every point you already graphed, or you can tell yourself from the vertex point, 1 over goes 1 up, and plot that. And you can say 4 over goes 2 up, and plot that, and draw your curve. So it's the same curve, it's just been shifted. Again, I did it to the left. I don't know what my problem is. Just do the same thing I just did, but shift it to the right. Having some issues with my right and my left today, apparently. You did the same thing? Only because you were copying me, probably. So I'm sorry. All right, here we go. Better. To the right, too. Okay. All right, so the next thing we do is this vertical compression by 1/2, and these are kind of the hardest ones, maybe. But remember, it's all about the relationship to the vertex. So the vertex stays. Nothing moves right or left, but the places that you had a point before, however far away from the vertex height they were vertically, is getting squished in half. So like this point was 1 unit above the vertex. Okay, it was up 1 from the axis. It now needs to be only a half because it's going to be half as big as it was before. So it's going to be down here. And this point out here was 2 units above the vertex, so where should it be now? Just at 1. Okay? So there, kind of squished it half as tall as it was before. Yes. We don't move anything left or right. It just kind of gets squished, just up and down stuff gets changed. Then we're going to reflect over the x-axis because it's a vertical reflection. So again, that vertex point is on the x-axis. It's not going to change. Okay? But each of these other points is going to get flipped over to the other side of the axis. So instead of a half above, a half below, and instead of 1 above, 1 below. And then the last thing you guys have to do is shift the whole thing up 1, and I'll draw the final product and post it for you guys. Okay? So your homework tonight is 5 problems. Okay? All right. Don't think I'm that weird. All right, so final product needs to go up 1. Bye, guys. So just move each point up 1. And then you have your new curve. The domain is going to be that x is greater than or equal to 2 because notice at 2 on the graph, all the points were to the right. And the range is going to be that y is less than or equal to 1 because notice the maximum height was 1 and the whole graph went below.